We all know that energy can neither be created nor be destroyed, but it can be transformed from one form to another. For example, wind turbines convert the energy from the wind into electrical energy. In the same way, nuclear power plants convert the energy present inside an atom's nucleus into electricity. To know more about this nuclear energy, continue watching. Hi, I'm Vanilla and you're watching The Learning Curve. Let's first see some basics of protons and neutrons because they play a major role in nuclear reaction. Every atom is composed of nucleus and one or more electrons orbit the nucleus. This nucleus is made of protons and neutrons. There is a strong nuclear energy between protons and neutrons that keeps them together inside the nucleus. In nuclear power plants, this strong nuclear energy is converted into electrical energy. Generally, there are two types of nuclear reaction. The first one is nuclear fission, in which a large nucleus is split into two nuclei. These two new nuclei will take part of the electrons of the large nucleus with them. Thus, two new atoms are formed. If we measure the mass of the initial atom and the total mass of the atom after splitting, there seems to be a difference. Some mass seems to be lost. This is because the mass that seems to be lost was converted into heat energy. During splitting, the strong nuclear energy is released, which is immediately transferred to the surroundings as heat. Second is nuclear fusion, where two nuclei combine to form one large nucleus. Fission is the type of reaction we use more often because that's the one we are good at controlling. But recently, there has been significant advancement in fusion science and technology. So, we can expect nuclear fusion power plants in future. The common fuel used for fission is uranium-235. The nuclear fission reaction is triggered by hitting this uranium-235 with a neutron from another source. When this excess neutron is added to the uranium-235, it becomes more unstable and splits into two smaller atoms, krypton-92 and barium-141. Along with these two atoms, 3 free neutrons were also produced during this fission process. These free neutrons split up some more atoms, which in turn releases more neutrons. This process continues again and again, and this will continue throughout the reaction material. This is called the chain reaction. An enormous amount of heat is released during this chain reaction. We can convert this heat energy into electrical energy the same way as the thermal power plants do. That's all for today. Bye. See you in my next video.